Later, Berzelius suggested that we can use the instead of writing pictures, we can use the first letter of English name. They are from the name we can take the first letter and we can represent these elements. For example, carbon can be represented. We can represent carbon as a C. C in the sense it is carbon. No need to write carbon every time while writing the chemical reactions. For boron, we can represent first letter is B, capital letter B. For hydrogen, we can write capital letter H. Iodine, capital letter I. And nitrogen, capital letter N. Oxygen, capital letter O. Sulfur, capital letter S. Uranium, so capital letter U. And fluorine, capital letter F. We can use the first letter from their English alphabets. The first letter can be used to represent the atoms or to represent the elements. Now, in some of the elements, some of the atoms or some of the elements, to represent them along with the first letter, we are using second letter also. But by representing them, we are writing first letter. Their alphabets, we are writing capital letter. The first letter can be written as capital letter, and the second letter should be written as a small letter. So aluminium can be represented as Al. L is small letter here. Al. The symbol of argon, it is Ar. A capital, R small letter. Barium can be represented as Ba. A small letter. Bromine can be represented as Br. Calcium can be represented as Ca. Cobalt can be represented as Co. O is the small letter, not capital letter. Co. Not to O capital letter. If you write O capital letter, it is oxygen. Here cobalt is Co. O is the small letter. Neon can be represented as capital letter N, small letter E, and silicon can be represented as Si. In some elements, along with the first letter, we use the main letter of that word. For example, instead of taking the second letter, the main letter which is present in that word we are considering. For example, chlorine. Chlorine can be represented as, we use capital letter C and small letter L. L is the main letter in this word, chlorine. So we represent this as Cl. Example, magnesium. We can represent it as capital letter M, small letter G. Magnesium can be represented as Mg. And zinc can be represented as capital letter Z and small letter Z. In some of the elements, we use their Latin words or the Greek words. Instead of writing their English name, we are considering their Greek word or the Latin word. For example, copper. Copper can be, we can write copper, it's a Greek word, is a cuprum. So we can represent copper as Cu. Cuprum, Cu. Gold is aurum, which can be written as Au. Iron is ferrum, which can be written as Fe. Lead is plumbum, which can be written as Pb. Silver is argentine, which can be written as Ag. And sodium is natrium, which can be represented as Na. So we use various ways to represent the elements which are present. So you have to remember the representation of these elements. This is the main thing to write the chemical reactions. So various ways. Some cases we are using the first letter of English alphabet, which is written in the capital, in the form of capital letters. Some cases we use first letter along with that second letter is written as a small letter. In some cases we take first letter and one more letter which is important in that word that can be taken to represent the elements, and in some cases we use their Greek words or the Latin words to represent the elements. So in this way we can represent atoms of different elements. Different elements can be represented using in these letters, or in this way we can represent. In the previous different elements using their symbols. So, the most important concept that Dalton's atomic theory was given by atomic mass. So, according to Dalton, atomic mass of an element, or he said each element has a characteristic atomic mass. So, scientists started to measure the atomic mass of elements, but it was difficult, the task was difficult to find the atomic mass of each element. It was impossible to find atomic mass of each element. So, the relative atomic mass was determined based on the law of chemical combination. So, in the year 1961, carbon-12 isotope was selected, it was chosen as the reference to find the atomic masses. So, carbon has mainly 4 isotopes, carbon 11, carbon 12, carbon 13 and carbon 14. In that, carbon 12 isotope was chosen as the reference, as the standard. So, atomic mass unit or 1 AMU, 1 atomic mass unit. 1 atomic mass unit, which can be represented as AMU, atomic mass unit, but at present it is represented as U. Can be defined as it is the 1 by 12, 1 by 12, the mass of 1 by 12, the mass of one atom of carbon 12 isotope. 1 AMU, 1 atomic mass unit can be defined. It is equal to 1 by 12 the mass of one atom of carbon 12 isotope. So, carbon 12 isotope was selected, it was chosen as the standard. So, what do you mean by this 1 by 12 mass of carbon 12 isotope? If you consider there is a pumpkin, the weight of pumpkin is 60 kg. There is a big pumpkin, its weight is 60 kg. A large, there is no 60 kg pumpkin, but still consider there is a very big pumpkin, its weight is 60 kg. If you divide this pumpkin, if you divide the pumpkin into 12 pieces, 12 equal pieces, 12 equal pieces. If you divide the pumpkin into 12 equal pieces, then mass of each piece, if you consider mass of each piece, it is 1 by 12. Mass of each piece will be how much? Mass of each piece will be 5 kg. So, if you select that one piece as the standard unit, if there is no weighing stones or there is no any weighing machines, weighing stones are present with the sellers, for example fruit seller, then to measure some other things he used to measure the other fruits, he used this piece as the standard unit. For example, to measure the weight of 2 apples, he take this pumpkin piece and he measure the weight of other thing. But here it is not vegetables, it is atoms. This is a case of atoms. So, 1 atomic mass unit to measure the mass of each atom. Carbon 12 isotope was used as standard unit. So, it is the 1 by 12 mass of one atom of carbon 12 isotope. It is called atomic mass unit, which can be represented by the letter U. Atomic mass unit can be represented as U. The letter U can be used, which is equal to 1 by 12 the mass of one atom of carbon 12 isotope. For example, if we write the atomic masses of different elements, if I write the atomic mass of hydrogen, hydrogen. Hydrogen atomic mass is 1. As we said, Dalton, each element has a characteristic atomic mass, different atomic masses. So hydrogen atomic mass is 1. If I consider carbon, atomic mass of carbon is 12. If I consider nitrogen, atomic mass of nitrogen is 14. Atomic mass of oxygen is 16. Atomic mass of sodium is 23. Atomic mass of magnesium, if you consider, it is 24. In the same way, atomic mass of chlorine is 35.5. So atomic mass is a characteristic property of an element. Atomic mass unit can be defined as it is equal to 1 atomic mass unit is equal to 1 by 12 the mass of 1 atom of carbon 12 isotope. Atoms do not exist alone. They combine to give molecules as well as ions. So atoms combine together to give molecules and ions. So molecules, what are molecules? Molecules are the group of two or more atoms. They are chemically held together by attractive forces, by the force of attraction. Group of two or more atoms. As I said, atoms do not exist alone. They combine and give molecules or ions. So, molecules are the group of two or more atoms. They chemically combine. Two or more atoms chemically combine and held together or bind together, by force of attraction, There are molecules of elements and molecules of compounds. Molecules of elements and molecules of compounds. So when you consider molecules of element, there are monoatomic molecules. There are diatomic molecules, triatomic molecules, tetraatomic molecules, and polyatomic molecules. Molecules of elements. There are monoatomic molecules, diatomic molecules, triatomic molecules, tetraatomic molecules, and polyatomic molecules. So what are monoatomic molecules? Monoatomic molecules in the sense, in these elements only same type of atoms are present. Same type of atoms in the sense, only one atom is present. The molecules containing only one atom, they are called monoatomic molecules. If you give the example of helium, neon, etc. These are monoatomic molecules. Come to the diatomic molecules. Diatomic molecules in the sense, they contain two atoms. For example, oxygen molecule, O2 molecule. We represent oxygen not as O. O is the representation of oxygen element, but oxygen molecule can be represented as O2 in the sense it contains two atoms of oxygen. Always during the reaction, if we write hydrogen combines with the oxygen. We write oxygen, we represent oxygen as O2 during the reaction because it is diatomic molecule. Diatomic molecule in the sense there are two atoms. In that molecule, two atoms are present, that is oxygen O2 molecule. There are triatomic molecules. So what do you mean by triatomic molecules? If three oxygen atoms combine together, we get O3. What is this O3? O3 is ozone. The formula of ozone is O3, which contains three atoms of oxygen, which is triatomic molecule. Triatomic molecule, three oxygen atoms present. That is three oxygen atoms O3, that is ozone. If you take tetraatomic in the sense if it contains four atoms, tetra means four. If it contains four atoms, it is called as tetraatomic molecule. You can give the example of phosphorus. Phosphorus, which is tetraatomic molecule, and if the number of atoms are present more than 4, it is called polyatomic molecules. You can give the example of sulfur. Sulfur is polyatomic molecule. So atoms do not exist alone. They combine and they give molecules as well as ions. Molecules or ions. Molecules are the group of two or more atoms. They chemically held together by the force of attraction. There are molecules of elements and molecules of compounds. Molecules of elements, there are monoatomic molecules, diatomic molecules, triatomic molecules, tetraatomic molecules and polyatomic molecules. Monoatomic molecule in the sense a molecule containing only one atom. You can give the example of helium, neon, etc. Diatomic molecule in the sense a molecule containing two atoms. We can give the example of oxygen molecule O2. Triatomic molecule in the sense molecule containing three atoms. Example O3, which is ozone. Tetraatomic molecule in the sense molecule containing 4 atoms, and if the molecules containing more than 4 atoms, we call it as polyatomic molecule. For example, sulfur. Now come to the molecule of compounds. Molecules of compounds. Molecules of compounds. Molecules of compounds. Let's now come to the molecules of compounds. So atoms of different elements, they join together with a definite proportion and they give molecules of the compound. If we take the example of water, water is a compound. One molecule of water contains 2 hydrogen atoms and 1 oxygen atom. 2 hydrogen atoms and 1 oxygen atom combined together with a constant proportion, with a ratio of 1:8. In a ratio of 1:8, and we get 1 molecule of water. So how this 1:8 ratio that I discussed in the beginning of the lesson. So water is a molecule. 1 molecule of water contains 2 hydrogen atoms and 1 oxygen atom. They combine chemically in the ratio of 1:8. The ratio of atoms of hydrogen and oxygen in a molecule of water is 1:8, and we get water molecule. When you come to the ammonia is NH3. Ammonia, which contains nitrogen and hydrogen, they combine with a ratio of 14:3. It contains 1 atom of nitrogen, 3 atoms of hydrogen. They combine with a ratio of 14:3, and we get ammonia. It is a molecule of compound because ammonia is a compound because it contains nitrogen and hydrogen. Both the 2 elements are present here. HNO3, they all are the compounds. So molecule of the compounds, they contain in which different atoms are held with a constant proportion. The atoms are held in a constant proportion to give molecules of the compound. Now we will go to the, as I said, atoms, they combine and they give molecule as well as ions. Now come to ions. What are ions? Ions are nothing but they are the charged species of atom. Charged species. Charged species of an atom is called as ions. There are mainly two types of ions. Which are the two types of ions? Positively charged ion and negatively charged ion. Positively charged ion and negatively charged ion. Negatively charged ion. Ion has positive charge as well as negative charge. So, there are positively charged ions as well as there are negatively charged ions. Positively charged ions we call it as cations. Cations are positively charged ions and negatively charged ions we call it as anions. Anions. If we take the example of sodium chloride, NaCl. Sodium chloride. It contains positively charged sodium ion, negatively charged chloride ion, Na plus Cl minus. So Na plus is which type of ion? Na plus is a positive ion which is called cation. Sodium is cation and Cl minus is anion. So molecules and ions. Ions are charged species of an atom is called ion. What is a molecule? It is a group of atoms. Group of two or more atoms. They are chemically combined. They are chemically held together by the force of attraction. We call them as molecules. And ions are charged species. They are the charged species. They of atoms are called ions. In ions, cations are present, anions are present. Cations are positively charged ions and anions are negatively charged ions. As you know that different compounds can be represented using their chemical formulae. Now the question is how to represent these compounds using their chemical formulae. How to write formula, chemical formula of a chemical compound. If you know the symbol of each element and if you know the combining capacity of the element. Symbol, chemical symbol and combining capacity. Combining capacity of the element. If we know chemical symbol, the symbol which we have studied, different elements can be given different symbols. So if we know properly the symbols as well as combining capacity of the element, then we can easily write chemical formulae for different compounds. Now the question, what is this combining capacity? So the combining capacity of each element, we call it as valency. What is valency? The combining capacity of the element is called valency. About this valency, you will study in detail in the next lesson of chemistry. So valency, just to remember this, valency is the combining capacity of the element. If you take the example, sodium, potassium, silver, their valency is 1. So we can represent them as Na plus 1, K plus 1, Ag plus 1. Their valency is 1. In the sense, plus 1. Na is plus 1, which means that sodium, usually these are the metals. So metals usually they give up electrons, they donate electrons. So when you consider sodium, potassium, silver,
magnesium, calcium. Magnesium symbol is Mg, calcium Ca. Its charge can be written as +2. Mg +2, Ca +2. If you take aluminium, Al, its valency is 3, which can be represented as a +3. Aluminium is a metal which usually give up 3 electrons, so the valency is 3, it is a +3. Now when you move to the non-metals, if you take chlorine, bromine, etc., their valency is -1. So usually when we are writing sodium, potassium, Ag, even though it is +1, +1, +1, usually if it is 1, we are not writing that 1. We just write plus. What does it mean? It means it is 1. So in the same way, chlorine, bromine, they usually take non-metals usually receive electron. They take the electrons. So they usually get the negative charge. So chlorine, bromine, they usually take only one electron, which can be represented as Cl -1. But 1 we are not writing. We are writing only minus. So Br minus, in the sense Cl -1, Br -1. When you take the oxygen, it is oxide, which is -2. Its charge is -2. In the sense, oxygen usually take 2 electrons. When you go to nitrogen, nitrides, it is -3. It receives 3 electrons. Valency of nitrogen is 3. So if you know properly the symbols of different elements, and if you know the charges, if you know the valencies, that is the combining capacity of the element, how many electrons participate in the chemical reaction, that is called the combining capacity of the element. The combining capacity of the element, which is called valency. If you know this, easily we can represent a given compound using its chemical formula. So this you have to remember. Na is +1, K is potassium, sodium, potassium, silver +1, magnesium, calcium +2, aluminium. These are the most repeated metals which we are using in our reactions. Magnesium, calcium +2, aluminium +3. Chloride, bromide, that is chlorine, bromine, their valency is 1, that is -1. Oxygen -2, nitrogen -3. So in this way we can write the charges of each element. So if we know this, easily we can write the chemical formulae. Students, now we shall write the chemical formulae of different compounds. So first compound I have selected here, hydrogen chloride. Hydrogen chloride, it contains hydrogen and chlorine. So symbols of these compounds, symbols, the 2 atoms, 2 elements present, hydrogen and chlorine. So symbols of these compounds can be written as, hydrogen can be represented as H, chlorine can be represented as Cl. So the valency. What is the valency of hydrogen? I said valency of hydrogen, I said it is 1. Valency of hydrogen is 1, I did not mention. And valency of chlorine, I said it is also -1, Cl minus I said. But usually while writing here, we are not writing the charge. We are not mentioning plus or minus. We just write the valency. Valency of chlorine is 1, valency of hydrogen is 1. But while writing the formula, this one goes here, this one goes to chlorine. So we can represent H, it is 1, Cl, this is Cl, it gets this one valency, that is Cl1. But usually I said 1 we are not writing, 1 we are not writing. It usually we write hydrogen chloride. We write using the symbol HCl. The formula is HCl. Come to the next compound, hydrogen sulfide. So the 2 elements which present here are symbols of 2 elements present here. One is hydrogen, another one is sulfur. So symbols can be written as, for hydrogen it is H, for the sulfur it is S. The hydrogen sulfide, hydrogen H, sulfur S. Valency of hydrogen 1, valency of sulfur it is -2, but usually we write the 2. We don't write the charge. So sulfur valency 2, hydrogen valency 1. Now this one goes to sulfur, this 2 goes to hydrogen. So the formula can be written, chemical formula can be written as H, it is 2, H2, S1, but S1 we are not writing, H2S, chemical formula of hydrogen sulfide. Now move to the third compound, carbon tetrachloride. Two elements present, one is carbon which can be represented as C, and one more is chloride, chlorine, which can be represented as Cl. Now come to the valency. Valency of carbon, you have to remember, valency of carbon is 4. Valency of carbon 4, valency of chlorine 1. So this 4 goes here, this one goes to carbon. So the formula can be written C1 Cl4, 4 to Cl. So CCl4. This is the chemical formula of carbon tetrachloride. Now come to the fourth compound, magnesium chloride. The two elements present, one is magnesium, another one is chlorine, can be represented, magnesium symbol Mg, capital letter M, small letter g, and chloride, chlorine symbol Cl. Now valency, valency of magnesium is 2, valency of chlorine 1. You have to remember valency to write chemical formula. Now this 2 goes to chlorine, this one goes to magnesium. So the formula can be written MgCl2. So magnesium chloride can be represented as MgCl2. Carbon tetrachloride CCl4. Here C capital letter, Cl together, representation of chlorine. Come to the hydrogen sulfide, hydrogen H2S, hydrogen sulfide. Come to the hydrogen chloride, that is HCl. So valency you have to remember, hydrogen valency 1, chlorine valency 1, sulfur valency 2, then carbon valency 4, magnesium valency 2. So when you are writing this, these valency gets interchanged. Valency gets interchanged. So we write the chemical formula in this way. Valency you have to remember. There is no other method to understand the valency. That is mainly you have to remember the number, the valency of each element. The element which are given in your textbook, their valency, the chemical formula which is asked to find out, their valency you have to remember.